Hello students, from this lecture I am going to discuss about the oxoacids of phosphorus. Again, these are the compounds of the phosphorus. So I'll write the heading um, oxoacids of phosphorus. Okay, the first oxoacid of phosphorus, I will write the formula, that is formula in the name. Majorly we will be studying throughout this lecture is orthophosphoric acid. Phosphoric acid. Formula is H3PO4. Structure. I will directly draw the structure. This is phosphorus, one double bonded oxygen, and there are three bonds connected to it. OH, OH, and this is OH. Now, what is the meaning of oxoacid? Why these are called as a oxoacid? Why oxoacids? So, answer is first thing is a central atom should have at least one double bonded oxygen. Central atom should have at least one double bonded oxygen. Okay. Um then acid, because it is having some hydrogens which could be removed. I'll explain you about that later. Um, then I'll talk about this. Okay, it should give, it should give hydrogens, right? And we call that to be acid. And that hydrogen should be attached to oxygen. Central atom should have compulsorily one double bond. So these are the things about the oxo acid. So how many hydrogens H3PO4 can give? How many hydrogens? Okay, question arises by looking at this acid. The question which may arise: how many hydrogens? Hydrogen H3PO4 can give. H3PO4 can give. If you just have a look at the structure, then there are three hydrogens, right? If I show these bonds in this manner, okay, it is OH, no? So I will show it in this way. OH. Here also it is OH, and this is also OH. Now here, if you break this bond, then there will be a hydrogen will be removed and minus sign will be there. Negative charge will be there on these oxygens, and the stabilization of that negative charge will be due to the resonance. Means if I want to remove this hydrogen, let's say I'll remove one of the hydrogen. I will just show for the one of the hydrogen. If I remove one of the hydrogen, then what will form? Because hydrogen is going to go as a H plus, right? So this is hydrogen. One of the hydrogen I am removing. And here that's why there is a development of the negative charge. If there is a development of the negative charge, then what happens? This is in resonance with this pi bond. Whenever something is in stabilization with resonance, that is more stable. So hydrogen can leave easily. This hydrogen can also leave. This hydrogen can also leave. Means all these bonds could be broken very easily. Means this compound is going to give me three hydrogen. The answer for this is, it is going to give me three hydrogen. Okay, and among oxo acid, this is the most acidic acid. So n factor over here is equal to 3. Oxidation state, okay, acidity. Okay, acidity. Second thing is acidity is, since 3 hydrogen it can give, it is tri basic, means to neutralize. Now what is the meaning of this? Tri basic means what? uh, to neutralize one H3PO4 structure, to neutralize this H3PO4 structure, since it gives 3 hydrogens, I will require a 3 moles of base. Okay, that's why it is called as a tri basic, and acidity is always given this way, tri basic. Okay, if two hydrogen, then di basic. Okay, if one hydrogen it can give, then we call that to be a mono basic. Now what is the oxidation state of a phosphorus over here? I will write the formula again. It is H3PO4, H3PO4. The oxidation state of this, okay, it is very important that you should know to calculate oxidation state of the central atom. So since there are three hydrogens, I will put this to be is equal to 3x, sorry, we know the hydrogen will have the plus one charge, and phosphorus I'll put x. There are four oxygens and each oxygen has minus 2 of charge, and overall compound is neutral, so this is 3 plus x minus 8 is equal to 0. So here it is, x will be is equal to 8 minus 3, therefore x is equal to 5. The oxidation state of this phosphorus is 5 over here. See students, I am discussing about the one of the compound. I have discussed one of the compound, that is orthophosphoric acid, and it is the first oxo acid of the phosphorus. We understood that at least one oxygen phosphorus double bond should be there, and this is how the three hydrogens could be removed from there, and there will be development of the negative charge on the oxygen, and that negative charge will be stable due to the resonance with a phosphorus, right? Over phosphorus oxygen double bond, there is a presence of the pi bond. Now, next question will be, what will be what will be the anhydride n anhydride of this acid? See students, you don't have to by heart any anhydride. If for exam they are do ask what is an anhydride, I'll tell you the simple technique. If you know this technique, you can apply it for the any oxo acid, and you can easily get the anhydride. The first thing is, I will write the H3PO4. If I want to find what is the anhydride of this acid means it is H3 PO4. This is the acid. So I will take this H3PO4. Just remember the steps to get the anhydride. You don't have to by heart at all. What will be the anhydride of these things? Because you have to by heart other things also. And if you know some things by tricks, then this chapter will become more easy. So this is H3PO4. You do a dimerization. Okay, dimerize first. Now what is dimerize? Just make it double. In short way, I will say that change this formula, means change the number of atoms to a double. Like hydrogen is 3, you will make it 6. Phosphorus is 1, you will make it 2, and oxygen is 4, here you will make it 8. Now how many water molecules you can remove from this? Remove as many as water molecules possible. At this step I will write remove remove maximum possible H2O molecules. So how many water molecules I can remove? Since there are 6 hydrogen, I can remove just 3 H2O. So minus 3 H2O I am writing over here. So this is the step, and it will be applicable for all the oxo acids, minus 3 H2O. So how many oxygens are remaining? 5 oxygen will be remaining. Means in this compound, since I have removed 3 water molecules, I will be writing all hydrogens are gone. There is P2, P2O5. Okay, P2O5 you are writing. Now what you will do, then you should dimerize it again dimerize this, and it is P4O10, and this is a anhydride. This is a anhydride anhydride of H3PO4. Name of this compound, I will write, name of this anhydride is tetra phosphorus phos deca oxide deca oxide. The thing is very simple. Take the acid, dimerize it, remove as many as water molecule as possible. Then whatever compound you are getting, then again dimerize it. Okay, this is the anhydride of this acid. Now, with respect to structure, if I want to show steps from here to here, like H3PO4 dimerization means what? You take two molecules like this. You take two molecules of phosphoric acid. Okay, another molecule I'll take dimerization. That is what I am doing, right? So now when I am writing this structure, there is no any bond I have written, but you can just show uh, this type of things in between. Like I will write a hydrogen, and this side I am writing hydrogen. There will be some hydrogen bond which is holding this. Right now, if you remove one water molecule, now at this level, this compound which I have drawn is H6P2O8. Means I am talking with respect to this. Okay, I am talking with respect to this. Then remove as many as water molecules you can remove, and you will get a P2O5. Okay, that is the thing, and this is the structure. So what is the structure of P4 anhydride? What is the structure of P4O10? That is anhydride. I'll show on the next page. P4O10. That is phosphorus. Here it is phosphorus, and here also it is phosphorus. There are four phosphorus. I am connecting it. There will be oxygens also here. I'll put some oxygens. Now I'll connect this phosphorus oxygens. Okay, there is one more phosphorus oxygen linkage. See how I'm drawing this structure. I'm just putting one oxygen between all the phosphorus, right? One more phosphorus oxygen linkage. This is not a bond. It is like this. It is crossing over it. And finally, what you can do is just put double bonded oxygen, double bonded oxygen on each phosphorus. This is the simplest structure you can draw. You can see that phosphorus and phosphorus, there is always oxygen. Phosphorus, there is oxygen. Phosphorus, there is oxygen. In between, there is no direct phosphorus bond in this case. So here each phosphorus is sp3 hybridized. So these are the things about the um, oxoacid of phosphorus, that is a orthophosphoric acid. So I'll stop this lecture over here. In the next lecture, I'll be doing a next for oxoacids of phosphorus.